Well, welcome back, folks. So yesterday wasn't a hell of a fun day around here. So three things of note happened. One is my wireless microphone stopped working, and I recorded an entire video, which has to be thrown out. And I did things in the video that I can't undo. So remaking that video is going to be tough. It's not going to work out great. That leads me to why the audio is so crappy on this. I'm just using the in-camera microphone. Next thing happened was that we had a bit of a storm here. Now, yesterday started off great. Before noon it got up to 28 degrees, which for you guys down in the States is 82. And then the storm came in, and then we get up this morning, it's 1 degree, which is less than 34 for you guys down in the States, and it's snowing. And during that storm, the third thing happened. That is, we had multiple rapid power failures in a row. Now, we've had that happen around here. I live in a rural area. We've had that happen a number of times over the years, and bad things always happen. So what happened yesterday was the pump controller went. We pump our water out of a well, and I made a microcontroller-based controller for the pump, and it blew the hell up. So we had a bit of a run around this morning and late last night trying to get the pump going again, and that was lots of fun. So I spent most of the night not sleeping, trying to think about how the heck I could prevent this from happening again, because we've lost lots of things. We've lost a satellite receiver, TV satellite receiver. I've lost test equipment. I've lost a projector, an LCD projector. We lost a TV, all from exactly the same sort of thing, where the power goes on and off rapidly, maybe 10 or 15 times over the space of a minute, because some tree is bouncing on the hydro lines. So yeah, thinking all night what I could do to prevent this from happening. And the solution I came up with is to create a latching switch. So a switch where you push a button, the thing then latches on, and if the power goes off, it releases, so that the power can then come on and off all at once, and then you don't have to turn the thing back on until you want to turn it back on when the power is stable. So I thought of various different ways of doing that. I think this way here is the best way. It uses a double pole single throw relay with a switch. So the switch drives the relay, and then one of the poles of the relay latches that switch, brings the power down through it again, and the other one sends the line out again. Another way to do it with a simpler relay, with just a single pole, single throw relay, would be to use a high current switch, so that switch needs to be able to handle the load as well. So it'll turn on, the relay will turn on, and the switch in the relay is going to be parallel across that one, so it'll take over the load. Either one of these, once the power dies, the coil will go dead and the relay will open up and won't come back on. However, I do not have a double pole single throw relay, and I do not have a high current switch. What I do have is a fancy looking, big, gorgeous, low current switch, so this thing will only handle 3 amps. But I have 2 single pole, single throw relays. So I'm going to order in this, because I can just use a simple, cheap switch to drive that relay, as long as it's good for 125 volts. And I think this is the best solution. Relays are a little bit more expensive than what they used to be at one time, but I think this is still the best way to go. So I'm going to build multiple ones of these for any of our sensitive equipment, and that's the solution I'll be doing going forward. But for today, I'm going to use this solution here. So this uses the 2 relays. The switch drives the first relay. The contacts of the second relay then act like, in this case over here, and turns on the second relay, which then pulls in the contacts which are across these contacts, and then it latches on until the power goes out. So that's what we're going to do. We're going to build it into this case using these 2 relays, this switch, these little jumper wires here, and this 14 amp rated extension cord. So yeah, let's get started on that. I'm just going to lay this out here. I'll try to wire the whole thing up and we'll come back and we'll test it out. So I've got the basic layout done here. The two relays are going to be mounting, everything will mount to the lid. The two relays will be mounted in upside down like this, and the switch will be mounted here. This will eventually get mounted to the bottom of my bench here, and the cables will come in and out of these two holes here at the back. So, all right, time to drill some holes. All right, so we've got the basic constructions all finished. I've gone through and I've checked to make sure visually that all the connections are made according to the schematic here. And all the splices have been done with double layers of heat shrink tubing, and it's the kind with the hot melt glue in it. For safety's sake, I've put in here strain relief by using these whopping great big tie wraps here. So we should be good to go with some basic testing here. So we're going to test for continuity and for shorts, make sure all of that works out the way it's supposed to before we plug this thing in. So let's check on the input here between load and neutral, or line and neutral I should say, and it should be an open circuit. Don't touch it with your fingers. So that should be an open circuit, and it is. And now when we press this button, we should get the resistance of the coil of the first relay, which was about, I'd say around about 2.5K when I measured it before. So yeah, there we are, 2.4K. And now let's check to make sure that ground goes all the way through. This should be a near short. It is. Now, you should make sure that neutral goes all the way through. This again should be a near short. And it is. And we check here between the input line, output line, this should be an open circuit. And it is. Now let's check between line and ground, that should be open circuit. And between neutral and ground should be an open circuit. Alright. Now let's check on this side of things. So we can check against the ground here. Between the ground here and line. Ground here and neutral. And we've already checked the ground, it goes straight through. Now I'm going to need another probe for my next test. Now on this side I want to measure between line and neutral, and what we should see here is the resistance of the second coil, again 2500 ohms, and that's exactly what we see. Pressing the button shouldn't change that because the second coil can't be activated without power. And for between here and here we should be open, between here and here we should be open. Okay, so that all checks out. At this point now I'm just going to assemble it, and then we're going to plug it in and check it out for operation. Let's just put 2 screws in for now. Again, I'm sorry about the audio, but well, we have to find out what's the matter with those wireless microphones of mine, whether they need to be tossed in the garbage or what. So I have a light plugged in here. The light's normally on. I normally use it as a shooting light, and then I'm going to plug it in over here to a switch. And okay, so I just switched the power on, so it's got power coming in here, and now we're going to press the switch, and the light came on. Okay, now I'm going to turn the power off. Okay, I hope you saw that. And actually I'm going to turn this light off here to make it a little bit more obvious. turn the power back on over here and hit the switch. Power comes back on, off, on, off, yeah. So the first power failure, this thing will release, and then finally when the power does stabilize, you come down, you hit the switch, and you're back up in operation again. Alright guys, I hope you enjoyed this. I know I'm going to enjoy the benefits of having this. I'm glad I made one, and I'm going to be making a whole bunch more. I've got my other bench over here where I have my irreplaceable vintage computers, and then I'm going to have another one at least for my pump, and then a fourth one for our entertainment equipment. And I might have a couple of spares knocking around just in case. Thanks for joining me, guys. If you like, hit like. If you want to see more stuff like this, hit subscribe. Share it with somebody if you think it's interesting enough, and come back again. We'll see you later. Bye-bye. Thanks.